YouTube homework number 4. Number 1. A. Draw a free body diagram for the book. Um, so I got a tension force of the rope on the book. There is a normal force of the table on the book. And there's also a gravitational force on the book. B. How do the forces exert on the book in this case compared to the forces exert on the book when the string is not present? So in both cases, the gravitational force is going to be the same, and the tension force is going to be different. Also, the normal force. There is going to be an additional tension force if there is a string. 2A, consider the following statement made by a student and do you agree with that student? So basically, I said no, I disagree, because by Newton's third law, two forces in pair have to act on different objects. In this case, the student described two forces acting on the same object, which is the book, so I disagree with him. B. Consider a book on top of a level table, but the book is being pressed straight down. So this is the free body diagram. I have a normal force of the table on the book. There's a gravitational force pulling down on the book, and there's also a pushing force by the hand on the book. So in both cases, um, the gravitational force is gonna be the same no matter whether you're pushing down on the book or not, and the normal force is gonna be different. If it would be less if there's no F push by the hand, and there's gonna be an additional vector F push by the hand. So BIII is the magnitude of the weight equal to the magnitude of the normal force. I said no, they're not equal because the book is not accelerating, and by Newton's second law, F net have to be equal to 0, and F net is equal to the normal force of the table on the book equal to the gravitational force and the pushing force of the hand. So by this equation, as you can see, there's no way that the gravitational force is going to be equal to the normal force of the table on the book. Part C. Which force complete the Newton third law action-reaction for a pair with the normal force exerted on the book by the table? So I said that it would be the normal force exerted on the table by the book. And then which force complete the Newton third law of the force pair with the weight of the book? And I said that it would be the weight force exerted upward on the earth by the book. 3. A chain is suspended by a rope as shown in the right. So this is the free body diagram for link 1, 2, 3, and 4. And I identify all of the Newton third law action-reaction pair in my diagram. So this is the first pair, this is the second pair, and this is the third pair. Part C, rank from larger to smallest the magnitude of all the forces on your diagram. So the way I rank them is that 1 would be the greatest, and then 2, 3, or 4. Since link 1 is on top of the rest, is F net have to be equal to the tension force equal to the mass of 234 multiplied by G. For link 2, the F net would be the tension force equal to the mass of only 3 and 4 multiplied by G. So the higher you're on top of the change, which means the more weight you have to carry, And instead of when you're just at the bottom, you only have to like carry your own weight. And by Newton's second law, force equal to mass times acceleration. So basically, the more mass you have to carry, the bigger the forces that you're gonna have. Number 4, let S sub 1, 2 represent the system consisting of link 1 and 2 of the change in problem 3. Draw and label a free body diagram for system 1 and 2. So this is my free body diagram. I have a tension force of I have a tension force of the rope on system 1 and 2. I have a pulling force of change 3 on the system, and there is also a gravitational force pointing down. For each of the forces that appear in your diagram for system 1, 2, list the corresponding force on my diagram for 1, 2. So I got that the tension force of the rope on 1, 2 correspond to my tension force of the rope on 1, and the pulling force of change of link 3 on the system correspond to the pulling force on the change on chain 2 by chain 3. Are there any forces on your diagram for link 1 and 2 that you did not list? So I did not list the pulling force on change 1 by 2, so F12, and pulling force on change 2 by 1, so F21. So my reasoning is that they're within the system, so I did not break the system down into individual part and then include the individual forces that act on them, and also their Newton third law action and reaction pair. Let's see represent the system consisting of the whole change. Draw and label the free body diagram for C. So this is my free body diagram for system C. So there's a tension force of the rope on system C, and there's also a gravitational force of the Earth on system C. As you can see here, I did not include any of my action reaction force here for this diagram. The block is at rest on an incline, as shown below at the right. Draw a free body diagram for the block. I got a normal force perpendicular to the surface of the ram on the block. There's a gravitational force pointing directly down. There's also a pushing force of the hand on the block pointing directly down, and there's a static friction force that prevent the block from slipping. Part B. For each of the forces that appear on your free body diagram, identify the corresponding force that complete the Newton third law. So I got pushing force of the block on the ram corresponding to the ram on the block. The pushing force of the hand on the block correspond to the block on the hand. The friction force on the block by the ram correspond to the friction force of the ram on the block. The weight of the earth on the block correspond to the weight of the block on the earth. Ci is the magnitude of the net force on the block greater than, less than, or equal to the magnitude of the net force on the block. So the magnitude of the net force would be the same because since the block is not moving by Newton's second law, F net have to be equal to 0 in both cases. So they're equal to 0. Is the magnitude of the friction force exerted on the block by the incline greater than, lesser than, or equal to the normal force. So I said that the magnitude of the friction force is less than, because now the pushing force is directly opposite to the normal force of the ram pushing up on the box, and the only force that friction have to oppose now is just the x component of the force of gravity instead of um, the x component of the hand pushing down, like in this case, in addition to the gravitational force. So the friction have to be less than. 6. A person pushes a book against the wall so that the book does not move. Draw a free body diagram. So I got a gravitational force pointing down, a static friction force pointing up. There's a normal force um, on the book by the wall. There's also a pushing force by the hand into the wall. For each of the force that appear in your free body diagram, identify the corresponding force that complete the Newton third law. So I got that the pushing force of the hand on the book correspond to the book pushing back on the hand. The pushing force of the book on the wall correspond to the wall pushing back on the book. The frictional force on of the wall on the book corresponding to the book on the wall. The gravitational force of the earth on the book corresponding to the weight of the book on the earth.